So we're starting the notes for Algebra 2 on section 8.4, which is about exponential functions. So our goal is to be able to graph exponential growth and decay functions. So exponential functions have the form y equals a, that's a constant, times b, that's a constant, to the exponent, x is a variable, minus h plus k. So we usually think of those as something like the vertex or the inflection point, but it's really a horizontal shift and a vertical shift. So we're going to do two concrete examples and then we'll look at them in general. So just like we always do with a parent graph, we're going to start by making a table of values, plot the points, and show the shape of the graph. Nice small values for x, plug them in and find y. I'm going to plug the x value in, I'm going to do the work to the right, and I put the answer in the y column. So when x is -2, I put 2 to the -2. That means reciprocal, so I get 1 over 2 to the 2, so that's 1/4. Then for x equals -1, I get 2 to the -1. That means reciprocal, so 1 over 2 to the 1, which is 1/2. Then I put 2 to the exponent 0. Anything to the 0 is 1, so that gives me 1. Now I put 1 in for x, so that gives me 2 to the 1, which is 2. And likewise, 2 to the 2, which is 4. So now let's plot the points down here. So we get -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. And we connect them and we get a nice smooth curve like this. And as it turns out, we also get a horizontal asymptote. Remember asymptotes? So the curve is not going to cross the asymptote, so we get an asymptote there. So that's a horizontal asymptote. So that's the general shape. This happens to be exponential growth. Growth, things that grow get bigger. So as we go from left to right, we get bigger. Let's look at this example over here. We're going to do the same thing. Nice small x values, plug them in here. This time our b is 1/2, which is small compared to 2, which was big, or at least bigger than 1/2. So plug in the -2, I'm going to do the work to the right, put the value in the column. So I get 1/2 to the -2. Negative means reciprocal. Reciprocal of 1/2 is 2, so I get 2 to the +2, which is 4. 1/2 to the -1, that means reciprocal. So 2 over 1 to the 1, so that's 2. 1/2 to the 0, I'm plugging in 0. Anything to the 0 is 1. 1/2 to the exponent 1 is 1/2. 1/2 to the exponent 2 is 1/2 times 1/2, which is 1/4. So let's plot these. So I have -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. Looks similar, but it's going the other way. So it starts big, and as we go from left to right, it gets small. And I'm never going to get a negative value because no matter what I put in for x, I'm just doing reciprocals. So it'll be a small number, but it will never go negative. So it turns out I have a horizontal asymptote. I missed a little bit, but horizontal asymptote right there. And this is exponential decay, which we'll go into in a minute. So in general, exponential growth, both of the forms are the same, but the values that get put in are different. So if we have something of the form a times b to the x minus h, all plus k, that's in the exponent, that's not. If b, the base, not the a, but the base of the exponent, is greater than 1, so big like the 2 was, we get growth. We're talking about the growth column. And the general shape of exponential growth is like that. And the domain, because x can be anything as we go from left to right, we get everything, is all reals. And the range, what can y be? from bottom to top, I have that horizontal asymptote that I can't go below. So y is greater than k, whatever that vertical shift is. And we also have an asymptote. And it's a horizontal asymptote, and it's at y equals k. Now we're going to talk in general about decay. So that was my second example on the previous page. Same exact form, y equals a times b to the x minus h, all plus k. But in this case, b is less than 1, but it still has to be positive. And that gives us decay. It starts big and gets small. So the domain is still going to be all reals. As we go from left to right, we get every possible input. And the range, a range is a description of what y can be. So as we go from bottom to top, I have a horizontal asymptote. So I don't have stuff below there, but I have everything above. So it's always going to be y is greater than k, exactly like this. And we also have an asymptote. And it's horizontal, and it's at y equals k. So now a couple more examples. So let's graph this one, given the information we gathered up there. So we're going to graph. We want the equation of the asymptote and also to graph the asymptote and the domain and range. So I have b, which is 6. That's important. And since 6 is greater than 1, that's big, and that means we have growth. So it looks like that. It's bigger than 1. And it would be to the exponent x minus h, and then plus k on the outside. So k is 3. And that's important because that tells us the horizontal asymptote is at y equals 3. So let's put that on there while we know that. So I have a horizontal asymptote at y equals 3. Okay. And I know I have this general shape and it's above the asymptote, so I've got this. Let's get one more effect. How about if we find the y-intercept? Y-intercepts occur when x is 0. So I get y equals 6 to the 0 plus 3. Anything to the 0 is 1, so 1 plus 3 is 4. So the y-intercept is 4. That's helpful. That's enough to get a nice rough sketch. So I know the general shape. I have a y-intercept. That's my graph. We also need to find the domain and range. So the domain, what can x be? We know from above what it's going to be, but let's look. As I go from left to right, can I have everything? Yes, I can. So it's all reals. And the range is what can y be? So from bottom to top, I don't have anything down here. I don't have anything until I get above the asymptote, which we already knew from above. So y is going to be everything greater than 3. So that's the range. Example 2, another function. So I have a, which is 4, times b, which is 5 to the x. B was important, so let's write that down. B equals 5. 5 is greater than 1. So that means we have growth. So that means the general shape is going to be like this. Good to know. And then we might need the horizontal asymptote. So that would be based on k. So what is k? K is added on the end. There's nothing added on the end. So let's make it a 0. So k equals 0. So that means there's a horizontal asymptote at y equals 0. That's important. Let's put that there. Horizontal asymptote at y equals 0. All right. And now we know the general shape is like this. So we're almost ready, but let's get one point in the right place. So let's find the y-intercept. Y-intercepts occur when x equals 0. So I would put in 0 for x. So that would be 4 times 5 to the 0. I cannot do 4 times 5 because I always have to do exponents before multiplication. 4 times 5 to the 0 is 1. Anything to the 0 is 1. So that's 4. So the y-intercept is 4. All right, and we know the general shape, so that's good enough. So now let's talk domain and range. So domain, what can X be? Everything from left to right is a possibility. So we get all real numbers. What can the range, what is the range? The range is what can Y be? Bottom to top, do I have stuff everywhere? I do not have values down here. Bottom to top, I don't get anything on my graph until I get above the asymptote. So that means Y has to be greater than the horizontal asymptote, which happens to be 0. Last problem, here it is. So again, let's talk about what is B. A is 1, it's not here, times B. B is 1/3. This is the first one where it's smaller than 1. That happens to be smaller than 1. So that means I have decay. So the general shape is like this. So we know what to expect. And then we need to figure out what K is. That's H there, the -6. The plus K is 0. So K is 0. So what does that mean? That means that horizontal asymptote that we need is at Y equals 0. So let's put that in. Horizontal asymptote at Y equals 0. So there it is. And we know we have decay, so we start big and get small. So let's find the y-intercept just to have to one point to put in the right place. So the y-intercept happens when x is 0. So y equals 1/3 to the 0 minus 6. So if I simplify that, I get y equals 1/3 to the 0 minus 6 is -6. -6 means reciprocal, so that gives me 3 instead of 1/3 to the +6, which is 729. So that's really big and clearly off my graph. So I'm just going to change my scale and say this is 729. So I got a point right there along the y-axis. And what was my general shape? Decay. So I start big, get small, go through my y-intercept and head toward the horizontal axis. I changed my scale a ton, but that's the general shape. And lastly, I want domain and range. So domain is what can X be. Notice as I go from left to right, I have everything. So it's all reals. And the range is what can Y be. Well, I have to be above that horizontal asymptote. So Y is greater than that asymptote is at Y equals 0. So Y is greater than 0. So now you're ready to try the guided practice, numbers 1 through 8. So please try all of them. There is an answer key available.